What is the most used man-made material on Earth? You guessed right. It's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic podcast. And today I have Scott I can't even say your last name, Scott. Say it for me. DiLoreto. There it is.
You're not the only one.
And I'm already on a great start. So see, Tim. See, I got Scott and Tim from FullForce with me today. These guys are fiber experts. So they're on here today. Scott, why don't you do a better intro than I did?
I'm Scott DiLoreto. I've been with FullForce Solutions since September of last year. Been in the industry for 22 years now, I think, somewhere around there. Most of my career has been in concrete chemicals and admixtures and stuff like that. And I've had a couple of stints in specialty products. Tim and I go way back. He was a batch guy and I was a new admixture rep out in Oregon. So we've known each other most of those 22 years.
Nice. And Tim?
Yeah, Tim Hartsell here. Again, been in the industry like Scott since I was knee-high to a grasshopper. Started when I was about 16 years old, setting forms, doing footings. Been in it ever since. I took a little stint, about 2 or 3 years, did something else. I thought I'd get out of the concrete world. Got back started out as chipping trucks, shoveling under bins, then started driving trucks, went from driving trucks to dispatch, from dispatch to quality control and operations. And then back in 2007, I got into the fiber world. And since then, I haven't turned back. This is where I'm at.
Yeah. So you try to get out of concrete too. I heard someone tell I tried to do that too for about 5 years, but I never could fully get out of it because once people know that you were in concrete, they always ask you concrete questions. I found out, and also I had someone tell me before that the concrete industry is like the mob. Like once you're in, you never get out. So
it's true.
Yeah.
The other great thing about the industry, it's got a lot of opportunities for people that, like I said, I started at the bottom, chipping trucks, shoveling, and you can, if you had the drive and the passion for it, sky's the limit in our industry. There's a lot of opportunity to grow, and it's good, make a good living for people.
Oh yeah, that's it's been good to me. I started way at the bottom. I was at the lowest part of my life when I got into concrete. So it's been an uphill struggle ever since.
It's fed my wife her whole life. Her dad was a batch guy for what's now Cal Portland in Seattle. So
oh, nice. That's concrete. A small company.
Little one.
I think I've heard of it before.
Yeah, they we're gonna get sidetracked, and then we'll get into what we're here talking about. But you were mentioned them. I saw a YouTube video, and they were showing they were giving a guy a tour of their cement manufacturing facility, and I can't remember where it was at, but it was cool. They've been at that same location for like 120 or 130 years, so they had the kilns from the 120 years ago still there. They never demoed them. They just, they weren't using them, but they kind of showed the transition through the century, almost century and a half, as they, progressed with the technology. And the guy pointed to the bottom of they were up on one of the buildings, and he's pointing to the bottom of the hill there. And he's like, yeah, those are the kilns they used 120 years ago. That was again, as a concrete nerd, I thought that was pretty cool. But
That's pretty cool.
Yeah. Anyhow, so we brought you guys came on today to help me and our listeners further our education on fiber reinforcement. And Scott, you want to kind of talk about what, I guess, overview of what we're going to talk about today?
Yeah, kind of the general direction that we wanted to talk about was kind of doing a more holistic approach to concrete slab design. And we want to throw out some thoughts on sustainability, the resilience of concrete, and some better ways for constructability and controlling costs.
All right. Well, if you want to start us off, are you, I guess, when you want to look at slab design, are you talking about, are you guys getting a hold of projects, I guess, at the beginning of, or the conception of the project
that's our preferred place to get in, is in the design phase. It makes it a lot easier. We do have the ability to convert things and change things after the bid process as well too.
So Seth, it's just harder. I'm sorry. Our slogan is exactly that: from concept to design to placement. We want to be in that spot where we help all the way through. There are so many things that can happen through the process, and we like to help where it's not just a product and we turn and burn. When something goes wrong, everybody's looking at each other trying to figure out, well, what happened? What's going on? We like to stay through the whole process to help make sure that the end user, the owner, gets what they're looking for and what they paid for.
Yeah. I mean, that's everybody's preferred. I'd like someone to pick us as their concrete contractor before they even put a pencil to the piece of paper. That's ideal. But I imagine that reality is what, what I'm seeing is you guys are brought in to maybe value engineer or help out. In that case, I would say the majority of the time versus at the design level. Is that a correct statement?
Yes, sir. That'd be correct. We come in a lot when projects are already bid. We work with people like you guys and other contractors throughout the company and for the country, and come up with an option that'll work for them, that's constructible, but also, as you said, value engineer it.
Yeah, because just still it seems like everyone's really busy. Design is starting to get, I think, maybe caught up with what's going on. I don't know. It's kind of hard to read, but I know if near the end of last year, it seemed like we were waiting for designers to catch up, and I think maybe they're starting to catch up and get some of these projects out there. And by that time, I think they're exhausted. And because we reached out on a project about doing some, let's call it voluntary value engineering versus the mandatory value engineering, because everything's over budget these days. And we reached out, and it seemed like they were like, let's get through these mandatory value engineering things first before you guys start tossing new ideas at us. Yeah. So anyhow, but Scott, what when you say holistic view of slab design, what do you mean by that?
I think we've always just continued to do things the way we've always done them. And I like to look at things as a whole systems package, from the soil on up to the top of the finish of the concrete.
And everything in between.
Not just one little aspect of the whole process.
Yeah, there's just so many variables, Seth. So many things that can go wrong, and that's one of the things you got to keep your finger on. But one of the things I wanted to point out right out of the gate, a lot of times we just overcomplicate it. I like to use the acronym KISS, keep it simple, stupid, and that's one of our focuses. Make this. There's a few things. We're going to talk about a lot of the common issues. There's a lot of them, but there's some little things, pretty easy things we can do that I'm not saying that it completely eliminates a lot of those common issues, but can definitely help us control those issues and reduce those variables, things that could happen to your concrete slab, to your concrete pavements, which is kind of what we're talking about today, is a little bit more on the pavement side in general. So a lot of these little things we're going to talk about will really just help out, but keep it simple. Don't overcomplicate it. Don't chase it with a bunch of chemicals and a bunch of different things. Just keep it simple.
Mm-hmm. All right. Well, you want to roll into those common issues? Is that a good place to start?
I can do that. So, common issues, this is pretty much 101, but, we'll run through them. Subgrade finish, concrete mix design, concrete finish, reinforcement, joint placement, restraint's a big one. Mother Nature really gets us a lot of the time. That's one of the biggest factors, is Mother Nature. And, improper curing.
Oh, yeah. I like that one. We've been doing that forever.
Right?
It's one of those favorite topics of the day in the concrete industry, I think. Yeah, no, all those things are, man, we could spend a good 5-10 minutes on each one of those things. So you're saying there's more to a slab design than just the slab itself. There's other things involved with it, is what you're getting at.
Exactly.
Yeah, and you can take all of those. We could talk about, we have multiple influencers within all those challenges we just talked about. You got a geotech, you got a civil structural engineer, you got an architect, you got ready mix, your GC, your subcontractor, all these people doing different things to make this product work. But all these different people have different ideas on how it works. So a lot of times we're going in different directions. And if we can pull it all together, and work on the accountability side where we got somebody in charge of this, and that's where we like to come in and help with those things. Let's look at the big picture. Let's pull everybody together and create a successful project.
Make sure everybody's rowing the boat in the same direction.
Yeah.
Right.
Exactly.
Yeah. Yeah. Again, that's the perfect world. We don't live in the perfect world.
It's our hope and dream.
So what's the since we're living in a dream right now, Scott's dream. What's the perfect project for fiber?
Well, non-structural applications are the perfect projects for fibers. I mean, fibers there's a value all the way through with fibers that, they do a multitude of things. Sometimes I get a little leery about talking about everything they can do, because then sets people back a little bit. But we'll cover that here in a few, the value of the fibers. One of the things we want to look at is just, we talked about earlier, Scott brought about from subgrade up all the way through to the top of the slab. How do we produce that? All these other things that are happening from the subgrade up. What can we do to eliminate some of the issues that come along with that? And we have some ideas and some thoughts that could help with that as well.
Okay. Well, what are they?
I thought you'd never ask. Subgrade. Let's start there. That's a big issue. There's so many things that happen with the subgrade. Big one's settlement, right? We know that happens. What we realize in the industry, let's talk about how everybody segregates and takes their own little thing. There's a long time all we did is focus on the reinforcement side of it, via fibers. We really had to take a step back and realize, okay, well, if we really want this to be successful, let's start with what can we do for the subgrade? What is out there? And, I used to work for a company. It was part fiber, part geosynthetic products. And it always kind of surprised we'd never married the two, because, subgrade settlement's a big one. What can we do with that? We do a lot of different things, cement soil stabilizations. But we found some products that, they work mechanically. It's like a geocell. By running a geocell, we're able to eliminate cement treated soils. You reduce a lot of the labor, haul off, and things like that. But we're also able to take these and create a higher K factor. With a higher K factor, by doing that, and making sure we add that added insurance of the geo products underneath our concrete, we're able to take that and take the concrete and a lot of times run it a little bit thinner than we typically would than of the concrete section, because if we know it's on a solid foundation, then that gives us the opportunity to do so. When we don't know that, as designers, we always have to go in and go a little thicker. We have to think of the worst case scenario. And we still got to create a safety factor in there. Don't get me wrong. There's, it's not like the end all fix all, but that's where we start with it. It's in that area.
Yeah, that's one of those areas that's going to help with the overall cost and sustainability. Kind of all rolls in with stuff like that.
Yeah. So what you guys are saying, you spend a little bit more money on your subgrade, and what we mean by subgrade is the dirt underneath your slab. So did you guys see, while we're talking about subgrade, down in Miami, there's a I forgot what project it is, but they're mixing, they're like drilling down and using this thing that basically looks like a egg beater. It goes down the ground and mixes cement with the soil to improve the subgrade. So I think folks are figuring out, if you spend a little bit more on your subgrade, that there's some cost on the structure itself above, which there's been technologies out there for a long time that have been doing that seem very simplistic, and are very economical, at least in my experience, like geo piers, where they go down and they beat stone into the ground, and that improves the subgrade and allows, like you said, Tim, there should be some savings on your concrete slab that sits on top of that, right?
Yeah, because they've had to over design it for the failure of the soil in the past, and now we have the ability to design the soil to the structure that we're trying to put up.
Right. So what kind of things do you guys see in the slab design that compensate for poor subgrade? That would be like a flashing light to like an owner or GC that's out there, and they're looking at drawings, or even a concrete contractor that wants to help out with value engineering. If they see, what would they see in slab design that should be a flashing light to them that say, hey, this is to compensate for bad subgrade?
The reinforcement. Are we building a bridge over this bad subgrade? That's a big one. They over design the thickness as well. Those two things are big key indicators. But like I said, we look at what do they got going on with their soils? Are they doing anything for them? Is it just, they're going to clean it up, put 6 inches of base rock and pour? Maybe that, then you got good soil conditions. So we do take a look at that all the way through. When we're looking through plans, we make sure we understand that.
All right.
That's where it starts.
Okay.
The product we found, it's been around for a long time. It was actually developed by the Army Corps of Engineers. It's a very interesting product. They designed this product for when they had to go into the desert and made landing strips, and they can use sand. We can use, lesser quality aggregates, which again is a greener way to look at things. But they'd go in and they'd use this product, place it, and they'd be landing planes in a couple of days versus trying to build runways, or even sooner than that, a day. But it's been around a long time, and it's proven itself. It's a really neat idea, neat concept. The interesting thing is nobody's ever married the two. Well, why aren't we using this under pavements? Why aren't we using this under concrete? It's just as Scott said, in our industry, we would get really stuck into doing what we've always done because we know what to expect. There's enough things that happen, so people get real comfortable staying in that space.
And what is that product again?
It's a geo cell. You can go anywhere from 4-inch, 8-inch cell. It's little cylinders, and you can place this. Really, all you got to do is clean up the grub, get your grade, pull this product out, and then fill the cells in.
It's like a big honeycomb.
Yeah, that's what I was thinking you guys were saying.
Yeah.
Yeah, someone was. I saw something. I think it can be used as a soil stabilizer too on
That's exactly
embankments and stuff, right? Yeah, I was looking at it for my backyard. My backyard's a mess. Anyhow, so spend a little bit more on your subgrade. That's some good advice. What else you got?
What we're learning though, real quick, is it's not really spending more. We've learned, there's times that we have to over excavate. Like out here in Oregon, there's projects where we're over excavating, 2.5, 3 feet, backfilling with base rock, or we're doing cement treated soils. Again, with this one, you clean it up, you get your grade right, you put this down. You can save you a lot of money on just the trucking, moving material, equipment to move material back in. We're finding it's actually more cost effective a majority of the time.
Oh, okay.
Often you can reuse the native aggregates on site that you've excavated, just put them right back into the geogrid, and you get the an X factor on your K value, and you don't have to truck stuff out and bring newer stuff in to the site. So you save. There's oftentimes a lot of savings, not necessarily an added cost. Just that it's just added thinking about it ahead of time and not after the fact.
Okay, I gotcha. All right, I misspoke. Yeah, no, that's so spending more time on thinking about your subgrade, and I think there's folks out there that are doing that. Yeah, it's just those projects that seem to wait to the last minute to get things going. They don't give you ample time to address the subgrade. Seems like, but
we can just, we live on. It's going to shrink and swell, especially when you got exterior pavements. There's things, it's going to move. When you put traditional reinforcement, or if you don't have a smooth subgrade, just rutting from, pulling trucks on, it's happening. I know we're trying to get the job done. But little things like that cause restraint. If you got a fixed object, let's say rebar is not going to give, right? I mean, you got a fixed object inside a product that wants to move back and forth. There's a lot of other ways. We can talk about monolithic footings, other things that cause restraint. But something's going to give. And most of the time it's concrete. And that's why we'll have a lot of cracking. So one of the things we like to do is let's go through and look at all the different ways that we might have restraint in these slabs. Let's let concrete do its thing. Let's let it move. But a lot of it back to that subgrade, making sure we have a smooth finish on that subgrade is very important to having success with a slab.
Yeah, can we talk a bit about the restraint around columns, just for my personal
edification?
My personal knowledge. All right, so what as far as restraint around like columns and say you're building let's say you're building a data center, and you got the slab and it there's around the columns there's kind of a detail there that I'm trying to remember off the top of my head, but basically the slab sits on top of the foundation or pile cap at the column. So what would be a good way to make sure that condition there isn't restraint there that would cause undue cracking?
And one of the things I was going to point out, even another restraint is, like you said there, anytime we pour directly on, say, a footing or around areas like that, it is important to put, most of the time we're going to be using this an interior slab, so we're going to be using a vapor barrier, which reduces that restraint. It turns into a slip sheet. A allows concrete. It gives you a disconnection between that, or even grade beams. When you run grade beams, leave those exposed. I learned this the hard way. Had cracks, throughout those buildings. Like, we did everything right. Well, we really didn't. Where we had those grade beams, they didn't use a vapor barrier. And that was another valuable lesson for me way back when I started this. We didn't have that slip sheet there, but you have to disconnect those things. You have to keep it as flat, and your thickness as consistent as you can throughout the panel. So there's different ways you want to disconnect those. The other thing, I like to do a pinwheel or a diamond off those and cut off. We like to really just we extend joints, and we prefer to do that, but we like to stay within the column lines. So, usually they're around 55, 65 feet, somewhere in there. And then off of those points, we like to use a saw cut.
Gotcha. Those. Yeah, the pinwheel's so the diamond around the columns. So you leave out a diamond shaped around the columns, right? And and when you pour the slab is what I'm trying to explain to you all. So you leave that space around the column, and then you go back and pour that afterwards, after a period of time. That's what you're talking about.
Yeah.
What's that?
And sometimes that's done first. Yeah. But yes, that's what we're talking about. Exactly.
Okay. So there's a separation between the
main slab, and the attachment point to that column.
To the column. Yep. I gotcha. Have you guys
Go ahead,
Tim.
We're working to create a floating slab. So we want to disconnect it. The load's going to be in the footing where those piers are, and then everything else, we want the slab to be free. Again, what I said earlier, we want to open it up and let it do what it's going to do. If it's going to shrink, that's okay. We understand how that's going to look.
Is there any benefit of getting rid of all the 90-degree angles? So you're creating a 90-degree angle in that pinwheel design, right? And you're doing it again when you do saw cuts. Is there any benefit to doing more of a, let's say, a circular or a circle leave out around the column? Have you all seen that?
I haven't had luck that way. I want to influence the crack. That's why we create that diamond. That's why we put joints in, right? We know it's going to crack, so all we're doing is make it a decorative joint. Or a decorative crack. Yeah, decorative crack. So really what we're trying to do is make it crack there. That's why we'd rather have that pinwheel or that diamond and cut off those corners. Most of the time, that's where we created that, we weakened that plane. We're going to open that up, and it's going to shoot through that and set it out in the panel somewhere.
Gotcha. All right. Yeah, I've someone mentioned that to me, I think on a podcast or maybe in a conversation. They said it's not a controlled joint, it's an influence joint.
That's right.
Exactly.
Yeah. All right. So we talked about having smooth surface that the slab can sit on, making sure that it can move and it's not restrained. What else is a good practice that we need to look out for?
Well, Scott, why don't you talk a little bit about mixes and things we can do to optimize mixes, before we get into the reinforcement side?
Yeah, I mean there's lots of different admixtures and cement contents and stuff like that we can do. All of our shrinkage happens in the paste, so if we can minimize the amount of paste we have, you're going to get that much less shrinkage. That's why going with a larger size aggregate, where you have less surface area to cover, you can use less paste on that, but that lends itself to being harder to move around because you're using the bigger aggregate. So it's kind of a compromise between the concrete place and finish guys and how much shrinkage you're willing to endure on that project.
Right. So yeah, I mean, like looking at your aggregates, going through the gradations, making sure we're filling those voids. As Scott said, the more voids we fill, we're able to fill with, every area is different. So, we have really good aggregates in some areas. Sometimes we don't. We have to find other ways to accomplish it. But that is key. making sure you go through that and take a look at that is key to making these slabs successful. Sure.
So
another thing too is there's a talk about the slabs, and I think you'll probably see this, Seth. I don't know if you've noticed, but there's more of a trend now with the water cement ratios. You remember when all they were doing was trying to drive that water cement ratio down. You couldn't place it. It wasn't constructible. It was hard to work with. There was other issues. I can put a laundry list of issues even doing that. You see now the trend is, that 0.50, maybe even a little bit more, 0.48, 0.52. You're seeing those water cement ratios in these interior slabs, reducing the admixtures and the chemicals that people put in and just making it a more constructible product to place.
Yeah. Yeah. So you're saying if someone suggests using fiber and doesn't ask for your mix designs, that you probably should run the other direction?
It's always good to make the whole system work, right?
Yeah.
And then, we can talk about fibers a little bit and go on to that. Start talking about reinforcement. Again, we're talking about rebar, it's fixed object. You can look at ACI. Your area still has to be X, if you're going to go joint free, and that's a lot of steel, a lot of rebar. But also talks about it's going to create a lot of hairline cracks. They're fine cracks, they're going to be tight cracks, but you're going to have a lot of cracks. The fibers work, as the concrete starts to develop microstrains due to the tensile stresses it's creating when it's building its tensile strength. The fibers, what they do is they capture all those microstrains, and instead of letting those cracks develop in one spot, you're distributing those cracks, millions and millions of cracks throughout the panel of concrete. That's how the fibers and the macrofibers work. It's pretty simple. People are really always trying to figure that out, like what's going on here, why is this working? That's how it works. But back to the mix design too. The higher dosage rates now, there's fiber doses anywhere from on the low end of macros is 3 pounds. I've been up to 10 pounds, but I like to not really go over 7.5 pounds unless we have to. But by doing that, fibers create surface area as well, and that's what Scott's touched on. We're talking about paste. That's where we come in, and that's where a lot of the failures are. People get a lot more fibers on the surface, a lot more fibers exposed because there's not enough paste to cover those fibers, that cover that surface area. That's why it's important to get to align yourself with people that will take a look at that for you. Again, I'm not trying to overcomplicate this. There's just a lot of resources, a lot of people in our industry that could take a look at that and say, okay, give me your mix. Let's look at your gradations. Let's look what you got going. We know we got this much surface area on our fibers. This is our recommendation. Or, it might have too much paste. And say, hey, we can lean this up a little bit. You got plenty of paste, and we can reduce that shrinkage.
Yeah. Is there a special way that you need to finish when you have a fiber mix, a mix with a fiber? So you don't have the infamous hairy slab?
You're not going to go through one of these conversations without talking about the hairy slabs. There's just no way to get around it. That's for sure.
Everybody's got one of those projects.
The best way for me to explain that, we're going to talk a little bit more about water retention in our slabs, how the fibers work as well. We talk about plastic shrinkage. We've already talked about drying shrinkage, helping with crack containment. We got a little bit ahead of the cart there. But, when we reduce the plastic settlement, for people that don't understand what plastic settlement is, when you're running a slump and your aggregates want to work their way to the bottom, your heavy, your coarse aggregates do. When they settle to the bottom, it creates and starts pushing the water up. When it pushes the water up, it creates these little channels called capillaries. And that's where the water escapes. So that's where when you'll see that bleed water, and you see those puddles of water on top of your surface, that's a key driver. There's other ways that happens as well. That's definitely a key driver. The fibers, if you imagine, you got all these fibers throughout the matrix, the concrete. We look and we call it, slump loss, parent slump loss. Well, the fibers don't absorb any water, but they make the concrete more cohesive because you're bridging all the materials together. They don't allow the aggregates to settle, push down. They keep all your coarse aggregates to the surface, and keeping all those consistent and the mix consistent throughout is key. So by doing that, then we greatly slow down that water migration that can escape and we slow that down and keep the moisture inside the concrete as well. That's what I'm talking about. There's a multitude of things that fibers can do. They don't only just hold cracks together when they form, but they help a lot as plastic stakes as well, where concrete's most vulnerable.
Yeah. I didn't think about that. That would be key. So so you're saying like the fiber kind of acts like almost like a net, keeps everything in place.
Correct.
As well.
Right.
And when we're talking about, we should clarify this. We're talking microfibers, right?
We're talking macros.
Macros. Okay.
Inch and a half to 2 1/4, 3
Okay.
pound minimum.
And the macros, just to clarify, macros are the ones that do a can replace structural,
can replace rebar for temperature and crack control.
Right.
Not for structural purposes.
Not for structural. Okay. All right. Just
we hear some claims, and that's, I know in the industry, I guess we're trying to find a place for that. So, most of your interior slabs, they're not structural. They do have load bearing capacity, and those are things we take into account. But, fibers aren't there for structures. We can't build a bridge out of fibers and fibers alone. That I just want to make sure we're clear there. It's not that we can't do heavy loads. We sure can. Anything that's, ground supported or supported by a deck, we can absolutely do that. But it's a combination of the ground support plus the fibers.
Gotcha.
So back to
go ahead.
I was going to say back to the hairy slab. One of the key things where I was leading with that is when you retain that moisture to keep it in the slab, which is what we want to do, it gives what a lot of finishers, it's a false set. It's not that it's set up any quicker. Your set time stays the same, but instead of having that bleed water come to the top where finishers are usually out, eating their sandwich, drinking coffee, or doing whatever they're doing, waiting for the moisture to come through, it gives that the concrete always have that haze because that bleed water isn't come to the top. And that's where, we'll prematurely get on the slab and start to finish it. When we're finishing that early, that's where we work the fibers of the surface. And it is a timing. It's something that skill set you learn over time. I mean, we got guys out there now that we do slabs at 7.5 pounds, 5 pounds, won Golden Trowel Awards where you just don't see a fiber. They get it. They wait until that, they don't get excited. They wait until, they think it's time to get on, and they wait longer. And it goes back to the old school, do the old, you step on it, just make sure, most people go in a 1/16 of an inch. I'd probably go in a 1/4 of an inch with the way I'm built. But anyway, you want to, it's all about the timing, and it is something you'll learn quick. But if you get on it too early and it's green, and you even get out there with your pans or what have you, and you start leaving that wake behind and you've got that paste coming to the surface, well, that paste, you got the fibers coming, and that's where you start chasing it. So timing is key. Your people out in the industry that do what we do, everybody can go out and help you with that. Like Scott goes out on jobs a lot of times and works with people, just making sure, especially if they're new to it, making sure their timing and things are correct. So that way, you get past the first one, you get a little better, then we don't have those issues.
Gotcha.
You use the QC that you got from your ready mix producer. They know their mixes, they know set times, and temperature plays a big part. The concrete temperature and the ambient temperatures will play a big part in that. How long it takes to set up and whatnot, and you can time it out fairly accurately just with math.
And it's all dependent on your mix design. So there's not a set time. There's like, hey, 30 minutes after you get it down, you guys can jump on it. It's going to depend job to job.
And job to job and mix to mix. And change into all the 1Ls and stuff that we're doing has popped up some set time questions. I mean, it's not anything that's not overcomable, but we just have to know what the issues are. And again, think about it before the actual concrete's on the ground. Have those conversations, have the open conversations about how long is this going to take?
Yeah. Even if you're, I was going to say, even if, I'm just thinking about on a job, you're making decisions from pour to pour. So if you're going to make any kind of adjustment from one pour to the next, if you're withholding water or anything like that, and then adding it when the truck gets there, all that stuff needs to be communicated to folks that are, fibers or whoever, right?
Yeah.
That would all have implications as well.
Well, and just changes in the weather will from day to day. I mean, if you've got a bunch of 80-degree days in a row and then all of a sudden it's 60 out, you're going to have, I won't say set time issues, but you're going to have a change in the set time because your concrete temperature is going to be lower.
Yeah, you have differential set too. If you're dealing with Mother Nature and your humidity drops and your heat goes up, well, that surface is going to take off a little bit quicker than the interior. So there's all things, and that's with or without fibers. That's just something that we got to pay attention to when we're out placing concrete.
Yeah, no, if you're in concrete, you have to be a chemist, a weatherman, and a logistics specialist.
Exactly,
and sometimes really lucky.
And lucky, lucky all the time. Yeah. All right. What other issues are there that we need to talk about before we end this one?
We want to talk a little bit about some of the new technology with the silicates or sodium silicates. I wanted Scott to talk about that a little bit. It's a newer technology. It's been around a while, but it's a newer technology. You're starting to see in the market a little bit more. One of the things we want to talk about again is we want to keep the moisture in. We want to be careful. ACI's definition of internal cure. Where's that at, Scott? Do you have that out there?
Yeah. So curing in and of itself is the ability to maintain temperature and moisture for time long enough to get the strength that's required for that mix. Internal curing is the process by which, I'll just read the ACI definition, process by which hydration of cement continues because of the availability of internal water that is not part of the mixing water. And that's from ACI Concrete Terms in 2018. And we want to make sure that we help that process along. And one of those ways is using a sodium silicate type product to make more concrete hydration product in your concrete. And concrete's a great big gray sponge. Back in probably around 1970, the construction industry came to the cement and concrete folks and asked to build faster, gain strength faster, and build with more water so they could pump it and whatnot. And so we ground the cement finer, which allowed more surface area. It reacted faster. They were able to use less cement, more water, and that caused more permeable concrete, which allows our water to escape from the concrete. By putting in a product like a sodium silicate, you're able to close those pores back up and maintain that moisture content in the concrete for a longer period of time.
Which is key. That is key to making all this work. I'm a huge believer in these products, the sodium silicates or the nano technology. Again, it's just you utilizing the moisture that's already there. We're not adding moisture, so we're not going to say we're internally curing, but we're optimizing. We're holding on to the water that's in there and giving the concrete its best shot for success.
Have you guys been successful in getting that in the specs for, let's say, replacement for wet curing? Because it's still all these specs I'm looking at. I haven't run across one yet that says, oh, by the way, you have this option of internal curing.
I've been successful in several areas. I've worked in different parts of the country. And I do know of some specs that are out there where it is an option. You can either wet cure it or you can use products like these to help with the curing aspects of it.
Was that is that DOT work or is that private work or both?
It's more, just private commercial.
Okay.
And it happens in schools and hospitals and stuff like that.
Yeah, I know there's DOTs in Midwest
Indiana.
Indiana. Thank you. That have it in there, but it hasn't hit at least over here in Virginia. Haven't seen it yet. I'm trying to get folks to look at it. I agree with you. I think it makes a whole lot of sense. The internal cure, it's not new, like you mentioned, but it's something that it's gaining a little bit of traction, I think, and it's I think it's because of the maybe because of the change to the 1L cement. It's maybe that's the reason, or it could be that there are some DOTs that have approved its use, and that's gained traction.
One of the things I think we need to learn how to do, and actually we're working on right now internally, is really how do you quantify? Where's the boundaries? How low of humidity, how high of heat can we go? Where we're retaining enough moisture to hydrate the cement to do everything it needs to do. And we're doing some testing. We're going some pretty extreme lows with the humidity and the heat, and then we're going to try to do a lot of testing, find out where that sweet spot is. That way, the industry has a place to start understanding. Okay, well, if your humidity drops below 30%, then you need to do a wet cure. If you're in between, I don't know what the number is yet. I'm just throwing some just round numbers out there. Just say you're above 40% and your temperature is below 90 degrees. No need for a wet cure. Those are some things we're working on. We want to give you guys, the people that place in the concrete, some guidelines so you understand and we understand. We don't want to oversell anything. That does nobody any good. So we really are determined to figure out where that sweet spot is.
I got you. So not just blanket across the board as far as curing, like chemical cure. That's why we're going to do the whole job, or wet cure. That's why we're going to do the whole job. Internal cure. That's why we're going to do the whole job. So you're saying we're going to complicate things a little bit and give us, in certain situations, this is what you want to do. Kind of like hot weather, cold weather kind of.
Yeah, it's your toolbox. You got different hammers, different tools that you use for different purposes. Sometimes you're going to need a topical help because the ambient conditions are too extreme. And sometimes it's going to be just fine working with the products that are internally in the concrete.
Yeah.
I think to that point, your topical cures like the actual 309s and 1315s, they only really need to be about 50% as effective as water curing to pass their ASTMs. And that's if they're applied in a lab at the appropriate square footage and with a decent shape and sprayer that's not all broken and had form oil in it and everything else.
Yeah.
That I like to add, Seth, is the durability. I mean, what's happening when we densify this concrete and we plug those capillaries, we're just products making concrete really dense. So we are like, well, let's check this out. Let's do some ASTM testing to see, what we do for abrasion. And we did some of the most aggressive abrasion testing out there. And come to find out, we did a lot of testing. Come to find out, we can compete with shake-on partners, the dry shakes, things like that, by using a combination of the fibers, using a combination of a sodium silicate and a topical that we use in the concrete. By doing that and densifying the surface, we're able to get rid of that shake-on. Shake-ons cause a lot of other problems. One of the key factors is delamination. You need enough moisture to hydrate that cement you put on top, or the dry shake you put on top. A lot of times you don't, and more often than not, you'll have some delamination in these projects. When you run this way, it's a simple process. It's placed, it's put in the mix, the ready mix plant. The top is put on by the concrete contractor, and it's just a one and done. Keeps it real simple.
Yeah. Well, I think we need to. I think you started the podcast on the keep it simple acronym there. When we start talking about doing all these different things and applications and internal things, I think the struggle is the cost, but also doing these things correctly. So I think when we start talking about doing things like that, in my opinion, I don't know if those are definitely not something that is good for every project, but definitely there's some applications there depending on what the owner wants and what they're in.
There's always applications for it.
Yeah.
So like with just changing out number 3s on 18s, and putting 3 or 5 pounds of fiber in there, you're actually probably going to have savings. And if nothing else, you're going to save time. You're going to save safety. You can save on insurance costs because you don't have rod busters out there tying rebar and stuff like that. You're saving on job site space because you don't have to store all that extra rebar out there. You don't have 40 extra trucks coming into the job site to deliver that steel. And you have maybe 2 or 3 truckloads go to the ready mix supplier to bring your reinforcement in the back of the truck. It's also in 3-dimensional throughout the concrete where the rebar is only in one plane and it has to be at a specific area of the concrete depth to be of any benefit or value to the crack control. And if it goes too high, then you get settlement cracking over that. And you got other forms of issues on the job site.
Yeah.
So there's a lot of benefits to adding things in the back of the mixer truck. And it doesn't necessarily have to add cost.
Yeah. No, I don't know.
More often than not, it reduces costs. Like Scott said, more often than not, it does.
Yeah, that's what we need to focus on. Not making concrete a premium, make concrete cheap. That's why concrete got popular in the early 1900s because it was a cheap building material.
One example I'd like to give, Seth, if you don't mind, we're talking about, going into projects. We were doing a project in Tennessee. And it's a little extreme, but it was 1 million square feet, number 5 at 18 on center, I believe. And his job, it would have taken 37, based off 40,000 pound loads of rebar, it would have taken 37 truckloads of rebar to bring that in. Using the macro fibers were at 5 pounds per yard, it was 2.7 truckloads. So, productivity, there's so many different ways you can see the benefit of looking at it that way. And that's a little bit more on the sustainable side, but it's something we need to pay attention to.
Yeah. Yeah, I don't know any rod busters that like tying number 3s, bunch of number 3s. Yeah, they get paid by the ton. You got to tie a lot of number 3s to make a ton. So.
Yeah, exactly.
All right. Is there anything else you guys want to go over before we wrap this one up? Did we hit on all the?
I think we're pretty good.
All right, good. Well, if folks want to reach out to you all and learn more about FullForce, Scott, you're on. I know you're on LinkedIn. You got a new email address.
Quite a bit. Yep. You can reach me email at scottd@FullForceSolutions with an S.US, and my phone number is 253-365-4437.
And Tim?
Mine is tim@FullForceSolutions.com. I don't think it's US on that. It used to be US with FiberForce, Scott. It's .com. And phone number is 541-580-9553.
Yeah. So we'll put that all on the show notes, and you guys can check it out. And when we put this up on LinkedIn, we'll make sure we put y'all's contacts on there as well. Scott and Tim, thank you for coming on the podcast today. I appreciate it.
Thanks for having us.
Yes, sir.
Hey, Seth, I do stand corrected. It is .us. My apologies, Scott.
And that concludes another episode of the Concrete Logic Podcast. I hope you got some value out of that episode and learned a thing or two. If you did, visit our website, concretelogicpodcast.com. Click on the Show Support tab and learn how you could be listed as a producer of an episode. Again, that's concretelogicpodcast.com. Click on Show Support tab to learn how you can support the show. And as always, Mike Dunton will take us out.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives. Dripping in sweat, working overtime. But while they're tying their ties for their